Hello! Welcome to General Chemistry 2. Today we're tackling the influence of temperature to reaction rates. Now, you might be thinking, what is the definition of reaction rate? Reaction rate is defined as the measure of how fast reactions occur. It is the change in the concentration of the reactant or product with respect to time. Some reactions occur quickly, while some reactions take millions of years to complete. Yep, that long! However, it is important that we study reaction rates because it is used for drug design, pollution control, food processing, and material synthesis. Now, temperature is one of the four main factors affecting reaction rates, along with concentration of reactants, nature of reactants, and the presence of a catalyst. Before going into detail, let's focus on the question, what happens during a reaction on the molecular level? Reactions occur when reactant molecules effectively collide. For an effective collision to occur, the reactant molecules must be oriented in space correctly to facilitate the breaking and forming of bonds and the rearrangement of atoms that result in the formation of product molecule. This is all according to the collision theory. During a molecular collision, molecules must also possess a minimum amount of kinetic energy for an effective collision to occur. This energy varies for each reaction and is known as the activation energy. The rate of reaction therefore depends on the activation energy. A higher activation energy means that fewer molecules will have sufficient energy to undergo an effective collision. An increase in temperature typically increases the rate of reaction. An increase in temperature will raise the average kinetic energy of the reactant molecules. Therefore, a greater proportion of molecules will have the minimum energy necessary for an effective collision. The kinetic energy associated with particles increases with temperature. As such, the more energy a particle has, the more it bounces around. The more it bounces around, the more likely it is to collide with another particle and yield product. For this reason, the rate of reaction greatly increases with temperature. On the other hand, it decreases as the temperature decreases. For example, you are at home one hot afternoon, and you want to drink orange juice. When preparing the juice, we use warm or hot water to dissolve the powder because this way the powder dissolves completely and quickly. We don't use cold water because it will take long before the powder dissolves and we'll get chunky juice. We basically took advantage of the water's high temperature to increase the reaction rate for this juice. Now, we can drink and be refreshed. Nice! Another one. To keep food fresh and prolong its shelf life, we put it in the refrigerator. The low temperature inside the fridge keeps the food from spoiling. Compared to leaving the food outside or on room temperature, this would cause the food to spoil fast. Basically, to decrease the reaction rate in food that eventually leads to spoilage, we put it inside the fridge, which has a low temperature. This way, we can safely eat the food even after a couple of days. Yum! Thanks, fridge! In conclusion, increasing the temperature increases reaction rates because of the disproportionately large increase in the number of high-energy collisions. It is only these collisions which result in a reaction.